This video covers Lesson 7 in Module 3 for your Eureka Math Level 7. This is over angle relationships and unknown angle measures. In our first question, we see that line DB and line EC intersect at point A. So we have DB, which is a line because it's got the arrows on the end, and we have EC. We also have ray AF because it has an endpoint and an arrow on the other end. Okay? So it says list all the angles we see and note any angle relationships you notice. Okay? Well, when we're looking at the angles here, when we name an angle, okay, we use kind of an L, okay, a leaning L, so to speak, and we start at an endpoint. Okay, for instance, I'm going to start here. I'm going to start at B. We start at an outside point. We go to the middle and come back to an outside point. So I have angle BAC, which is this angle right here. Okay, so BAC. Okay. I also have angle BAF. So even though there's this segment, this part right here of this line going through, we still have angle BAF. Because again, I start with an endpoint, I go to the middle, and then I come back to another endpoint. Okay. I also have angle BAD because I have, again, endpoint, middle, endpoint. When we name angles, we are naming them using 3 points, especially whenever you have multiple angles that come from the same center angle. Okay. In addition to angle BAD, we also have angle BAE. Now, BAE can kind of be 2 angles. It could be going all the way around here, or it could be this angle here. Okay, so BAE. Now, in addition to all these could also be written backwards. So BAC could also be written as CAB. When you're naming an angle, you start at the endpoint, go to the middle, come back to an endpoint. We don't ever start with the middle point. Okay? When you're naming an angle, you're following that path that you're listing. If that path doesn't make an angle, then we don't have, like if it goes, so if we were to say CFA, go C to F, well, those aren't even connected, so we couldn't say CFA. What we could say is CAF, okay? CAF, all right? Because we start at C, go to A, and then come here to F. We also have CAD, starting at C again, we have C to A to E. And then we could say CAB here as well. That's the same thing. So again, you could list it, or you could have, they are the same angle. Okay? If I'm just going around here, I still have F to A to D. So I have angle FAD. I have FAE. If I try to go FAB or FAC, I've already listed those. Okay, the CAF or the BAF. Okay, so going around to the next point, I have DAE. And all the others that have D in them, so it would be DAF. We already have that. DAC. We've already got that one. DAB. We've already got that one. So all of these that are listed, okay, again, you can write backwards to also label and name the points. Again, when you're naming a point, you start at an outside point, okay, go to the inside, and come back to an outside. So think of it like this. Outside, inside, outside. Okay. So when you're writing these down and you're writing these angles, make sure that you're writing those down in that order. All right. When we're looking at measuring angles, we're looking at a few different things. Okay. Starting here with, it says BGA. I want to know the measure of angle BGA. Well, it's X. Okay. BGA would form a special angle relationship with angle BGC. This box right here tells me that I have a 90-degree angle. So together, these two angles combine to make 90 degrees. Okay? These are complementary angles. Okay? So complementary angles this is some notes here that give us some background. Complementary angles are two angles that add up to 90 degrees. Okay? Two angles whose measures add up to 90 degrees. In this case, these two angles add up to 90. Well, I know that angle BGA plus angle BGC is equal to angle AGC. Well, we know that BGA is X. We know that BGC is 30, and we know that the overall angle is 90 degrees. Well, this is a simple one-step equation. Okay? In order to figure, and I know you can probably look and say, oh, well, I know that's 60. But mathematically, we have to eliminate, okay? So we're going to get rid of our constant number, okay? Do inverse operations. We want to get x all by itself. Okay? X equals 60 degrees. Okay? You could also just say, oh, I know that 90 minus 30 equals 60. That is correct. Okay? But we want to also be able to look and see how we can solve this mathematically, not necessarily or algebraically, not just, hey, I know this. Hey, yes, I'm going to tell you right now, look at this. That's 90. Okay, oh, well, that's 30. So 90 minus 30 gives me whatever's left. And that's 60. Okay. So again, when you're looking at the angles, we start at B, we go to G, we go to A. So this angle right here, that's the one we're looking for. That's the X. Okay, remember, outside, inside, outside. Okay, the space in between those lines there, okay, right here, that's your angle. In question 3, it says the diagram, it says angle DAB is a straight angle. Okay, that means it's 180 degrees. If I have two angles, okay, that create 180 degrees, so we have DAC and CAB. These two angles, okay, add up to 180. So that would tell me they are supplementary angles. Okay. The angle relationship is that they are supplementary angles. And what this means is, okay, I have two angles whose measures add to 180 degrees. Complementary, two angles add up to 90. Supplementary, two angles add up to 180. So in order to solve here, I would just say 180 minus 23. Okay, so that when I solve, I would get 157 degrees is X. If I were going to write the equation, it'd be X plus 23 equals 180. Okay. It says write an equation. Here's the equation. Well, how do we solve one-step equations? We do the inverse. If I'm adding, the inverse of that is to subtract. The ultimate goal is to be able to write and solve these equations here, not just simply rely on this, because as we get farther into this topic, we will have more difficult problems that have more steps than just simply taking and subtracting to find your answer. Okay. Part C, it says to check your solution to the equation. Well, if we said x plus 23 is 180, and we said that x was 157, I would just replace 157 in for x and determine if we do have a true statement. Well, if I add these two together, I get 180 degrees, which is true, so our solution works. So the measure of angle DAC is x, and we discovered that x was 157, so DAC is 157 degrees. If you're writing an equation for complementary angles, you add them together and they can equal 90 degrees. If you're writing an equation for supplementary angles, you add them together and it equals 180 degrees. Okay. So looking at question 4, it says complementary. Complementary means 90 degrees. So A and B are complementary. So angle A plus angle B equals 90. Well, do we know what angle A is, but we don't know what angle B is? Okay. Well, in order to solve this, again, we're doing the inverse. Since this is a positive number, we're going to subtract it to find our answer. Okay. 34.5 minus 34.5 is 0. So we would have 0 plus something, which is just whatever that is left over. In this case, it's angle B. Now, when I'm subtracting, don't forget we have to make this into a similar type number. Well, 90 is the same as 90.0. So when I subtract, I have to borrow again. I have 10 minus 5 is 5. 9 minus 4 is 5, and 8 minus 3 is 5. So angle B is 55.5 degrees. Okay, when it asks us to check the solution, okay, angle A plus angle B equals 90. Angle A was 34.5, angle B was 55.5. And when I add them together, I do get an answer of 90. 90 equals 90. Our solution is correct. Okay. The reason we're writing equations is to set it up so it makes it easier mathematically to solve. What we're doing here is we're solving equations by using inverse operations. That means the opposite. Okay, so the opposite of adding is subtracting. The opposite of subtracting is adding. Okay. The opposite of multiplying is dividing. The opposite of dividing is multiplying. Those are the things we're looking for when we're trying to solve equations. What do we have to do to solve the equation? Okay. So for question 5, it wants us to figure out the relation. First off, figure the relationship for this question for this angle here. Well, they add up to 90 degrees. Okay. So the relationship among these angles, okay, the angles form look here, we have a box. That box tells us we have a right angle, okay, which is 90 degrees. Right angles are 90 degrees. If you see the box, it's 90 degrees, okay, 90 degrees. Okay. So remember, we have 25 for one angle, x for one angle, and 25 for another angle. Because it's going to ask us to write an equation for this. Well, I know that the three angles add up to 90 degrees. I know one of them is 25, I know one of them is x degrees, and I know the third one is 25 degrees. In this case, we've got more than two terms. Our goal is to get each side down to 2 terms or less, and then there's a specific path that we can follow that we'll go through when we get even farther. But for instance, right now, first thing we want to do is combine our like terms. If you see like terms, and what I mean by like terms is terms on the same side of the equation, okay, so we wouldn't include 90 as a like term because it is not on the same side as these 25s. Right? So when I combine 25 and 25, I get 50. Okay. Since I'm adding 50 here, I will want to subtract 50 so I can get x all by itself, because 50 minus 50 is 0, and well, x plus 0 is just x. And then 90 minus 50 is 40. So x is 40. If we check the equation, we say 25 plus 40 plus 25 equals 90. Well, I've got 65, 75, 85, 90. 90 equals 90. Okay, that is a true statement. Okay. Part D, it wants the measure of EAD. That means we're starting at E, going to A, and going to D. Well, the measure of this angle is x. So the measure of angle EAD is x, which is 40 degrees. For question 6, I have all of these angles together that makes a straight angle. Okay, so this means that it equals 180. When you see a straight line, that is a straight angle. That measures 180 degrees. Okay, so it says to describe the relationship among CAE, EAD, DAF, and FAB. Well, I have all four of these. Okay, these are what we call angles on a line. Okay, and they add up to 180 degrees. When you have more than two angles that add up to 180, okay, we refer to them as angles on a line because they make a straight line. Okay. So again, since they add up to 180, I'm going to add every single one of these together. So I have x plus x plus x plus 3x. Okay. And right here, we're just combining all of our like terms. So I have x plus x plus x plus 3x. Well, this is 1x plus 1x plus 1x plus 3x. Well, 1 plus 1 plus 1 plus 3 is 6x. Now, this is different because we're not going to subtract 6 from both sides, because 6x really means, 6x means 6 times x. And in order to use inverse operations to eliminate the times 6, okay, the inverse operation of multiplication is just division. So I'm going to divide both sides by 6. Okay. Because 6 divided by 6 is 1, so that would give me 1x, which we've talked about is just x. And 180 divided by 6 is 30. So when we look at question C, it says check your solution. Well, again, x plus x plus x plus 3x equals 180. Well, again, we have 6x equals 180. So if I use 30 for x, 6 times 30 is 180. That's a true statement. So our solution is correct. Okay. For the measures of the angles, well, we know that the first three, CAE, EAD, and DAF, they're all just x. Okay. So I have CAE, which is x, so that means it's 30. EAD is x, okay, which is 30. However, CAD is different. It's C to A to D. Well, that's x plus x. CAD is x plus x. What is x plus x? That's 2x. Right? 1x plus 1x equals 2x. Well, when I have 2 times 30, because I'm replacing x with 30, that gives me 60 degrees. We know that FAB was 3x, so we're going to replace x with 30. And 3 times 30 is 90 degrees. Don't get fooled here when they're asking you to list, because they didn't list all of these single x's. They gave me one where I had to combine two angles. Okay, when you're combining the two angles, or more than two angles, remember, start with the first one. They said C, A, D. Okay. And lastly, question 7 here. It says AFE is a straight angle. Well, we keep talking about straight angles being 180 degrees. I want to know what the measure of BFA. So I want to know this angle right here. Well, in order to find that angle, I have to find the measure of x. And I know that all 4 of these angles added together combine to add up to 180 because it's a straight angle, a straight line, angles on a line. So I could say x plus 36 plus 36 plus x equals 180. Well, combine your like terms. X plus x is 2x. 36 and 36 is 72. Now we have here what we call a two-step equation. Because if we get rid of, we have to get rid of the times 2 and we have to get rid of plus 72. When I say get rid of, that's so we can get x all by itself. Okay. When you're doing a two-step equation, the first thing you want to look to get rid of is the number without a variable. Okay, this is your constant, so we're going to get rid of the constant. Okay, move the constant over. Well, how am I going to move it over? I'm going to do the inverse. So the inverse of plus 72 is minus 72. And 72 minus 72 is 0. 2x plus 0 is 2x. And when I subtract these, I get 108. Now it kind of looks like when we had the 6x. Okay, I have 2x equals 108. I've got to get rid of the times 2. What's the opposite of times 2? Divided by 2. That's your inverse. 2x divided by 2 is 1, or 1x. X equals, in this case, it would equal 54. Now, I also need to know that BFA is x degrees, which means the answer is 54 degrees. Okay. If I go back and plug 54 in here, I'm going to have 54 plus 36 plus 36 plus 54, which will give me 180 degrees. Okay. Make sure you double check your answer with what you wrote, okay, in order to ensure that you do have the correct answer.